morning students, how are you all? I hope you all are doing well. I am Mr. Prithviraj, I am your 9th class physics teacher. In the last class, we have completed up to our speed, velocity, average speed, average velocity and all. In this class, we will discuss mostly activity number 3. Actually, activity number 3 we have finished. Again, I will remind you what is activity number 3. Then we will continue with speed and velocity and observing the direction of motion of a body. These all things we will go through. So let me remind activity number 3. Okay, what it is? First, at that time we have taken example of 3 children in our playground. They should run from one point to other point randomly. Then in again another example what we have taken, in another example we have considered that they should run in a straight line. So in both of the cases we observed which is speed and which is velocity. So now I will give you a brief description about both speed as well as velocity. Here, what do you mean by speed? See. What is speed? What exactly is speed? It gives an idea about the object that is how fast it moves. Okay, it gives an idea about the object, that is how fast it moves. It is moving. Sorry, it is moving. Then the next part, what is velocity? Along with speed, it gives us an idea about direction. Along with speed, it gives us an idea about direction. Okay? So this is what we have completed in our last class. Today we will discuss about observing the direction of motion of a body. Activity number 4. What it speaks? It says that the aim is observing the direction of motion of body. This is what our heading. What your book says, carefully wheel a small object tied at the end of the string in the horizontal plane, then release the object while it is wheeling on the string. What is the direction does it move? He is saying to tie a object on a stone and move it in a circular motion. You need to wheel it. Okay? And at some point what you will do, you will gain momentum and you will just leave it. You will see in which direction it is going. Okay, that's what it is saying. So basically what we are doing, we are just moving the object. Okay, so while moving, you will see, suppose you left here, you will just leave here. So how it will go? It will move in a straight line, right? It will suit. How it is moving in a straight line? Exactly the point where you left on the direction of the tangent. It will move in a straight line direction. Right? See what it is asking. In what direction does it move? It moves in a straight line. The point where we left from that particular point, it has taken a straight line path. Okay? How? See, this is the momentum. Like this is what our circular motion stands for. If you are moving an object, if you are wheeling an object, you will leave at a particular point. It will move fast. Okay? At the same point where you left, and the direction will be equal to the tangent. Okay? What exactly is tangent? Tangent you will learn on your math class. Let me give you one idea about tangent. Let me do diagram over here. Suppose this is a circle. This is a point. This is our radius. Okay. Suppose this is our total part and this is our radius part. From here, the point touches. Here, what you need to do? You need to draw 90 degree. So wherever the 90 degree comes, that will be your tangent. So each point will have only one tangent, which will show the direction of the particular point. Okay? So in the direction of tangent, the body will move. Next. The SI unit of velocity is meter per second. Yes? What is the formula for velocity, students? Velocity is equal to displacement by time. Velocity is equal to displacement by time. Is it very clear? So displacement means the unit of displacement is meter and unit of time is second, right? That is meter, this is second. So obviously the unit for velocity is meter per second. If question comes in exam, what is the unit for velocity, then you need to write meter per second. Fine? Next. What is uniform motion? In our next topic we will learn what is uniform and non-uniform motion. To teach that, let me draw two paragraphs. I'll make two paragraphs space over here, then I'll draw two graphs. Okay? We have made two paragraphs over here. Now this side I'll draw one graph and that side again another one. Okay? Okay. This is called as distance time graph. What it is, students? Distance slash time graph. Same goes for that. Distance time graph. Okay. I think you all can see. Here we will consider this one, like y-axis as S means distance, small t means time taken, capital T means temperature, remember. Like that. Now we will take one example. Here it is given, a box is given. In that box they gave time and they gave displacement. First 0 second, 0 meter. 1 second 4 meter, 2 second 8 meter, 3 second 12 meter, 4 second 16 meter, 4 second 16 meter. That's what given. Okay. Now we need to plot this one at the graph. Suppose this is 2, 3, 4. Oh, sorry, from 1 we need to do, right? Okay, 4 slots we gave already. And here we will give 4, we will give this one as 8, this one as 12, this one as 16. Okay, now see it clearly, saying 0, 0, okay, first point is here only. Second point, 1 is 4, if 1, it is 4, okay, 2, then 8, fine. 3, 12, fine, again another one, 4, 16. This is also okay. 4 steps. Now we will draw a straight line over here. You can see it should come straight line. It should come a straight line. Okay. As you can see, students, here equal distance covered in equal interval of time. In 1 second it covered 4 meter. In the second he covered how much? Again 4. In the third interval he covered again 4 units. So here it is concluded that if time time is equal and the displacement occurred is also equal, then you will say the body is moving in uniform direction. So this is an example of uniform movement or uniform motion. What about non-uniform? The same, we will plot, suppose 1, 2, 4, 5. We will do 2, 4, 6, 8, 10, 12, 14, 16. Suppose in the first second he covered up to 2. In the second he covered up to 3. Then in the third second it covered up to 6. In the fourth second it covered up to 10. In fifth second it covered only 11. Students, as you can see, the graph is not a straight line. The graph is not a straight line. It bent, it curved. So in this case you will see what you can observe. In equal interval of time, it is not covering equal amount of distance. Right? So here in this case, we will consider these all things as this particular object is moving in non-uniform motion. Did you get it? Okay? Okay. So now next part, we will observe activity number 6. Okay? What exactly activity number states? Activity number 6 is all about observing the motion of a ball on an inclined plane. Observing the motion of a ball on an inclined plane. We will discuss in the next class. But in this class, what we have read? We have read about both distance time graph. Always you need to remember, students, if distance time graph comes a straight line, then you will say the object is moving in a what? Uniform motion. If it doesn't come straight line, if it not coming straight line, then you will say the object is moving in non-uniform motion. So both uniform non-uniform motion you all are clear. Now you need to do activity number 4 and 5. Your homework will be activity number 4 and 5. Practice nicely. Okay. so that you can understand properly, and read page number 18 also, page number 18, 19, from 16 to 19, read nicely. Okay, okay students, we will meet in next class.